This is lesson 3.2 on quadratic inequalities. Now remember in the last section, the last chapter, we talked about quadratic equations. And we saw that probably the by far the easiest way to solve quadratic equations was to factor them. So back in chapter 1 we looked at how to factor quadratic equations, and we also looked at how we can use the quadratic formula to find the solution. But that was, even though that was not too bad, far and away the easiest way to solve a quadratic equation was to factor it, if at all possible. Well, lo and behold, the easiest way to solve quadratic inequalities is also going to be to factor. And for our drill problems, we can count on all the problems being able to be solved by factoring. Now we may see a more difficult application problem where factoring is not going to cut it, but for the drill problems we can depend on the fact that factoring is going to work. So the way this is going to work is, regardless of how we do it, whether by factoring, completing the square, quadratic formula, we are going to use the zeros of the corresponding quadratic equation that we work with. So if we're given a quadratic inequality, if we just replace the inequality sign with an equal sign, that's the corresponding quadratic equation. So once we find the solutions to the corresponding quadratic equation, those are going to be the boundary points for the interval solutions for our quadratic inequality. So what we'll do is we'll find either 2, 1, or in some cases 0 zeros for the quadratic equation. That's going to split our number line into maybe 2 or 3 different intervals. What we will need to do is we will need to test each of those intervals to determine if it satisfies our original equation, or rather our inequality. But we are going to look at we will have an inequality where we're going to be comparing some quadratic function with 0, and that's where we'll focus. So it'll be easy to test if certain values satisfy that inequality, because all we need to do is determine whether we get a positive answer back or a negative answer back. So once we factor the quadratic function that we're dealing with, it's actually quite simple to find the solution for the quadratic inequality that we're working with. Okay, so let's consider the inequality x squared minus 5x plus 6 is less than or equal to 0. So this quadratic x squared minus 5x plus 6, I hope that we recognize this as one that we can factor pretty simply. Two numbers whose product is 6 and whose sum is 5, that's going to be 2 and 3. So we have x minus 2 times x minus 3 is less than or equal to 0. So what we're going to do is we're going to take our two solutions to the equation. So these are not solutions to the inequality. They're to the equation, so I'm going to go ahead and mark it as such. You won't need to do this, but just so that we're crystal clear. So we're going to mark these on our number line. So 2 and 3. What we want to do is we want to look within each of these regions and see whether or not this inequality is going to be positive or negative, since we are going to be comparing it with a 0, and that's what we always want to do. If we have something other than 0 here, move it over to the other side. We've got to get 0 here. We're going to compare it with 0 to see if it's positive or negative, bigger than 0 or less than 0. So what I recommend doing is for each of these regions, so we've got everything to the left of 2, everything between 2 and 3, and everything to the right of 3, just pick an easy number, just the simplest, easiest number that comes to mind. So easiest number that comes to mind here is 4. Between 2 and 3, that's a little bit more difficult, 2.5, but that's okay. To the left of 2, 1's easy, but 0's even easier. Be as lazy as possible. Make this easy for yourself. Now what I'm going to do is I'm going to plug in each of these numbers into these individual linear terms. I don't need to plug it in back up here. That's too much work. I need to do this quickly and all in my head. So when I plug in 4 for x, I get a positive number here, 4 minus 2, and a positive number here, 4 minus 3. So 2 times 1, so together that's going to be positive. I don't need to know the exact value. I just need to know if it's positive or negative. 2.5, similar story. When I plug it in here, I get a positive number back. When I plug it in here, I'm going to get a negative number back. So a positive number times a negative number is going to give me a negative number back. And last but not least, with 0, here I get a negative number, here I get a negative number, so negative times a negative is a positive. So we have figured out what's happening for each of these regions. Okay, now let's use this number line to help us out to find the final answer. So we know that the inequality is going to equal 0 when x equals 2 or 3. So that means that I'm going to put a closed circle here. When our quadratic function equals 0, that is okay because we want to find where this is less than or equal to 0. Okay, next I want to find where it is less than 0. So in other words, I want to find where my region is negative. So based on the work that I just did, I know that here I'm going to have is the only region where I have a negative value. So I'm going to go ahead and shade in this region right here. And that's it. I'm done. My final answer, my lower bound for this region is 2. I will include 2, so I'll use a closed bracket. My upper bound is 3. I also include 3, so I'll use a closed bracket. So there we go. There's my answer. Now let me show you a way that you can cheat. You go through these same steps, same first couple of steps. You're going to want to factor this out and find where the equation is 0. So you'll do the same story. So here's 2, here's 3. Now here's where things are just a little bit different. When I look at my original function here, notice my coefficient of x squared is positive. So that tells me that my graph is going to be opening upwards. I also know that the vertex of my graph, we mentioned before, it has to occur in between my two intercepts. So that tells me that my graph is going to look something kind of like this shape. Well, the only way for it to make that shape and go through these 3 zeros is if it looks something kind of like that. Pretend that goes through 3. Close enough. So based on what I know about the shape of my graph, I know that I'm going to have to dip below the x-axis between 2 and 3 and be above the x-axis to the left of 2 and to the right of 3. Or in other words, I'm going to be 0 when x equals 2 and 3 and less than 0 between 2 and 3. So once again, I get that my answer must be the interval from 2 to 3 inclusive. So take your pick. I want to show you this way because we're going to look at more complicated problems later, where this is really the way that we need to go. However, if you keep this in mind, if you're always mindful, what does the graph look like? You can use that to help you out. So this isn't terrible. It doesn't take a whole lot of time, but this is certainly a lot quicker. So if this makes sense and you're worried about time, I would encourage you, think about this, get accustomed to approaching things this method. So here's another one. Solve the inequality x squared plus 4x minus 5 is greater than 0. So let's go ahead and try to solve this one quickly. So we're going to factor this. So I believe x plus 5 times x minus 1 is going to be what we need. So on our number line, I'm going to put negative 5, positive 1. All right, since I have a strict inequality, I'm going to put open circles at negative 5 and positive 1 because I don't want to include them. And again, if I just remember, since my original function here, the coefficient of x squared is positive, I know that the shape of my graph is going to look something kind of like this. I don't know the exact shape, but that's okay. I know that my vertex needs to be somewhere between these 2 points. It's going to be opening upwards. Therefore, between the 2 points, it's going to have to be below them, and to the left and to the right, it will be above them. So we want to find out where it is positive. In this region, it's going to be negative. These 2 regions is where it's going to be positive. So that's where I'm going to get my answer. So my solutions are going to be the 2 shaded areas to the left and to the right. So this region and this region. So I describe that left region. My lower bound is negative infinity. My right bound, my upper bound is -5. I don't want to include it. It's a strict inequality, so I'll use an open parenthesis. And I'll union that with this region. My left bound is 1, and I don't have an upper bound, so I'll write it as infinity. So there's my final answer. If you are uncomfortable with this graphing idea, you can do the other way that we talked about. Just pick nice numbers in these regions, plug them in, figure out if you get a positive or negative number back. All we need here is to know if it's positive or negative. We don't need precise values.